Welcome to the Basics of Electrical Power Supply System module offered by Skilly. Skills, Jobs, Success. To know more, please log on to our website www.skilly.in. In the first session, Basics of Power Supply System, that is generation, transmission and distribution, GTD chain, will be explained. At the end of the course, you will have a thorough knowledge of electricity generation and transmission processes. You will have basic understanding of various components used in various supply system and the ability to choose the best according to the situation. You will also be able to read the electricity bill and how it is being calculated, how to measure the parameters of power supply on electricity meter. Importantly, you will learn to implement energy saving measures so as to minimize consumption of electricity and reduce the bill. So, it all starts with a child named Raj who was watching television at his home with his sister Ria, who is an electrical engineer. Let's begin the electrical journey. Okay, so coming to our first question. How does electric power supply reach us? So, the simple answer is GTD chain, that is generation, transmission and distribution. Have you ever wondered how the electricity, which is the basic requirement of today's man, reaches to us? Let's have a look at it. The first process is electricity generation. Here, the electricity is generated by converting some other forms of energy into electrical energy. Let's study in detail about it. So, this is the basic overview of entire power supply system. Electricity generation is the process of generating electric power from other sources of primary energy. The fundamental principles of electricity generation are Faraday's law and the law of conservation of energy. The law of conservation of energy states that energy can neither be created nor be destroyed. It can only be transferred or converted from one form to another. Electrical generator is the heart of substation. Generator converts mechanical energy to electrical energy. Therefore, in a plant, the basic aim is to convert any form of energy into mechanical energy which will rotate the generator. Generally, electric power is generated at low voltages of around 11 to 33 kilovolts alternating current with the frequency of 50 Hz. But does this question ever come in your mind? Why generation voltage in power plant is low? The reason is low voltage generation for particular power level requires large size of the stator conductors as huge currents flow through the stator. With larger the stator current, higher is the copper loss and the heat dissipated. Therefore, requires better and larger heat removing medium, thereby increase in the cost and size of the machine. Increase of the machine voltage significantly beyond the minimum necessary value results in requirement of more insulation for the generator stator windings, thus increasing its size and cost. Therefore, the generation voltage is kept low. So, now let us see different types of generating power plants. First one is thermal or steam power plant. In this power plant, the heat energy of coal is converted into electrical energy. Coal is burnt in a boiler which converts water into steam. The expansion of steam in turbine produces mechanical power which drives the generator coupled to the turbine. This type of power plant contributes to maximum share of India's total electricity production. Next is the hydropower plant. In this power plant, the potential energy of the water stored in the dam gets converted into kinetic energy of the moving water in the penstock. The kinetic energy then gets converted into electrical energy with turbine generator set. Third one is nuclear power plant. Here, the nuclear energy of a radioactive element like uranium is converted into electrical energy. As it can be seen from the picture that thermal, hydro, nuclear are base load plants. That is, they provide minimum amount of electricity continuously. The first cost, or say the investment cost of base load plants may be high, but its running cost should be low. Fixed cost is cost of land, machines and all the installation charges, and running cost is the cost of raw material, maintenance cost and transportation cost. Also, the plants which supply electricity during the peak time, that is during evening hours, or say some plants supply electricity only during the summer season, are called peak load plants. The biogas power plant, tidal power plant and pumped storage hydropower plant are examples of peak load plants. Usually, they have low fixed cost and high running cost. So during base demand, only base load power plants supplies electricity, and during peak demand, both base load and peak load power plant supplies electricity. After the electricity is generated, it has to be transmitted to the user's end. But since the generated voltage is low, so to transmit high power, current should be high. You must be aware that losses are proportional to the square of current. Hence, higher the current, higher will be the current losses and copper losses. Due to this reason and to avoid the losses, the voltage has to be stepped up to decrease the current. This is done with the help of step-up transformer in step-up substation. Since generating power plants are miles away from our home, it is necessary to transfer it from plant to our home. But since generating voltage level is low, which will cause higher losses, voltage has to be stepped up. It is done with the help of step-up transformer. So, this is how your actual transformer looks like. Obviously, the way bigger than you might have imagined, or from the one you might have used in your college practicals. Now, let's have a look and try to identify each part of a transformer. Let's have a look upon types of transformer, step up and step down. As the name indicates, a step-up transformer has many turns on the secondary winding than in the primary winding. Thus, the voltage supplied in the secondary transformer is greater. It converts low voltage high current to high voltage low current. In other words, the voltage is stepped up. It is known as power transformer 2. Generally, step-up transformers are located near generating power plants. Apart from that, these are also used in X-ray machines, and even a microwave oven requires a small transformer. You can see the electrical circuit of a microwave oven on the screen. Try to focus your view on the transformer location in the circuit. A step-down transformer is one that has fewer secondary windings than the primary windings. In other words, the transformer's secondary voltage is less than the primary voltage. So, the transformer is designed to convert high voltage, low current power into a low voltage, high current power. Step-down transformers convert 220 volt electricity to 110 volts. These are mostly used in domestic circuits and in domestic appliances. A very common application is the doorbell. Normally, doorbells use 16 volts, but most household power circuits carry 110 to 120 volts. Therefore, the doorbell step-down transformer receives the 110 volts and reduces it to lower voltage before supplying it to the doorbell. Now, let us discuss about the parts of the transformer. Transformer tank. This holds the transformer windings and its insulating medium. High voltage bushing. This is the terminal where the primary windings of the transformer ends and serves as an insulator from the transformer tank. Low voltage bushing. Like the high voltage bushing, this is the terminal where the secondary windings of the transformer ends and serves as an insulator from the transformer tank. The difference between these two terminals is low voltage bushings are smaller in size compared to the high voltage bushing. Cooling fins and radiator. In order for the transformer to dissipate the heat that is generated in its oil insulation, cooling fins and radiators are usually attached to the transformer tanks. Cooling fans can be usually found attached to the cooling fins. Cooling fans can be either a timer controlled or a winding oil temperature controlled. Cooling fans raises the transformer capacity during times when its temperature rises due to loading. Conservator tank. It is an oil preservation system in which the oil in the main tank is isolated from the atmosphere. System ground terminal are usually present in a power transformer whenever the connection type of the transformer windings has star connection in it. This terminal can be found in line with the main terminals of the transformer. Drain valve can be usually found in the bottom part of the transformer tank. Drain valves are used whenever oil replacement is necessary. Through this valve, the replacement of oil in an oil-filled transformer can be easily done simply by opening this valve like that of a faucet. Dehydrating breather. The location of dehydrating breather is shown in the screen. It is attached to the conservator tank. It is used to prevent the normal moisture in the air from coming in contact with the oil in electrical equipment as the load or temperature changes. This reduces the degeneration of the oil and helps maintain its insulation capability. When used with conservator system with a rubber air cell, it reduces moisture accumulation in the cell. Some breathers are designed for sealed tank transformers and breathe only at preset pressure levels. Oil temperature and pressure gauges are used for monitoring the internal characteristics of the transformer, especially its windings. These gauges help the operator in knowing the level of temperature and pressure inside the transformer, oil and winding. This will also serve as an alarm whenever a certain level is reached that could be harmful to the transformer windings. Bushing current transformers. Modern transformer construction today now includes current transformers. These are usually found around the transformer terminals, which will later be used for metering and relaying purposes. Its terminals are found in the control panels attached to the transformer. Control panel houses all of the transformer's monitoring devices, terminals, and auxiliary devices, including the terminals of the bushing current transformers and cooling fans. Control panels are very useful, especially when a remote control house is needed to be constructed. This will serve as the connection point. This is the 3D view of a transformer for better understanding and clarity of concept. After a quick overview of transformer construction, now let us shift our focus on the transmission. Once generated, electricity has to be transferred to the place of consumption. To execute this, there are transmission systems in place having transmission lines and substations as components. The electricity transmission is done at higher voltages to minimize losses. The farther the electricity has to be transmitted, more the level of voltage will be. Transmission systems are of two types: high voltage DC transmission system and high voltage AC transmission systems. There are certain advantages of AC transmission system over that of DC. AC voltages can be easily stepped up using step-up transformer and stepped down using both step-up and distribution transformer. This is not the case with DC systems. AC system is easy to adopt and its maintenance is also easy. That's why it is economical. There are factors like resistance and reactance in AC system that needs to be taken care of, and synchronization is to be done, but DC systems do not require synchronization. We hope you are aware about synchronization. It means matching of voltage levels and frequency. Even though with so many advantages, AC is preferred over DC because initial investments for DC is quite high. But for long distance transmission, HVDC system may be less expensive and suffer less electrical losses. Here you can see a typical transmission line. As the level of voltage is increased, the height of the tower is increased. So, from the height of tower, one can have an idea of its transmission power. Do you know a single disc of ceramic insulator can withstand a voltage up to 11 kilovolts? So, by seeing the number of discs, one can guess the voltage level of transmission line. Substation is a high voltage electric system facility. Substation is also used to change AC voltages from one level to another and or change alternating current to direct current or direct current to alternating current. Some substations are small with little more than a transformer and associated switches. Others are very large with several transformers and dozens of switches and other equipment. In short, it is a place where the power system is monitored and all the control processes are performed. Battery and charger are very important parts of a substation. They can be called as the heart of electrical substation. Battery rooms are required to provide continuous power for operation of switchgear, critical standby systems, and possibly blackout of the station when there is no AC supply to the substation. In a substation, DC is required for the operation of protective devices and other auxiliary devices. Now we shall discuss about the types of electrical substations: step up, step down, and industrial substations. With the step up and step up transformers details, anyone can easily guess about the location of these substations. Step up substations are installed near generating power plants. Step down substations are located at load centers before distribution. Bulk supply or industrial substation is generally a distribution substation, but they are dedicated for one consumer only. There are different levels of transmission voltages like high voltage, extra high voltage, ultra high voltage, and high voltage direct current. High transmission voltages range from 69 kilovolts to 230 kilovolts. Extra high voltage range from 345 kilovolts to 765 kilovolts. Ultra high voltage has only two levels of 1100 kilovolts and 1500 kilovolts. HVDC voltages operates at plus minus 250 kilovolts, plus minus 40 kilovolts and plus minus 50 kilovolts. As in case of any consumer goods, the availability of a product in shops is the final stage. Electricity distribution is the final stage in the delivery of electricity to end users. As we have already studied that except large or industrial consumers, domestic consumers are supplied the electricity by applying a transformer to the transmission lines or substations to reduce the voltage. Distribution system primarily consists of following components: step-down transformers to decrease the voltage level from transmission level to the level as required by the consumers. High voltage and low voltage bus bars. These are metallic strips or bars typically housed inside switchgear, panel boards and busway enclosures for local high current power distribution. They are also used to connect high voltage equipment at electrical switchyards and low voltage equipment in battery banks. They are generally uninsulated and have sufficient stiffness to be supported in air by insulated pillars. Feeders which connect consumers with substation. Circuit breakers that are used as a protective measure. Instrument transformers like current transformer and voltage transformer to insulate the metering circuit from the primary high voltage system. Different types of relays such as overcurrent, differential and earth fault relays, etc. The electricity coming from the transmission lines is at much high voltages and we don't require such high voltages. Therefore, the voltage level is stepped down using distribution transformers as required by the consumers and then distributed to different types of consumers. For generation of electricity, the voltage range is from 1.1 kilovolts to 33 kilovolts for transmission. Now we know that it must be higher than generation voltage. Therefore, it ranges from 66 kilovolts to 1200 kilovolts depending upon the requirement. There are different levels of GTD voltage levels. High voltages are 33 kilovolts, 22 kilovolts and 11 kilovolts. Low voltages are 400 volts if it is a three-phase distribution and 230 volts if it is a single-phase distribution. So, this is the end of session 1. In this session, we learned about the basics of electricity generation, transmission and distribution chain, that is GTD chain. We learn about different components of a generating power plant, transformer and its types, transmission system, substations and distribution systems. We were also able to find answers to some of our very basic queries. Why generation voltage is low? Why AC is preferred over DC? What is the difference between a step-up and step-down transformer? With the help of various useful videos, we now have a clear picture in our minds about the GTD chain, how it works, and how electricity reaches our home. In the next session, we shall have a detailed overview on the components of power supply system and what is SLD, that is single line diagram.